Python workshop held by the Informed Student Chapter in the IC department. Our speaker today is May. She is a PhD student and vice president of the Informed Student Chapter in the IC department, and she has done a lot of fantastic works in applying deep learning or neural networks in manufacturing systems. So let's welcome May.
Thank you very much, Yinan, for your introduction. And thanks everyone for joining today, and good afternoon. Today we are going to talk about data wrangling and analysis in Python, mostly using Pandas package. Data wrangling is about how to acquire and manipulate data with data science tools and to prepare it for the subsequent machine learning task or deep learning or just visualization. And we will use a couple of Python packages today, but our main focus is going to be Pandas. Pandas is popular for processing the data set and distilling the insights and trends from it. So this is the outline. We will follow the general data analysis pipeline, starting with reading the data into tabular structure called data frame. And we learn how to edit the inputted data by inserting and dropping columns and rows. And also we learn about reading the raw data. After reading the raw data, we are going to make it the right format and consistent format. For example, many times numerical values are stored as strings, so we need to convert them to the right format, which is numbers. Also, we are going to talk about how to handle missing values and how to find the cells that are empty and decide the values that we want to assign to them. After uniting the format and cleaning the data set, we then can explore and visualize the aggregated information and trends from it. So we will, the next step would be to explore, and then the exploration is the starting point for the learning tasks, but we leave machine learning for another time because of the limitation of time. So first of all the functions that we are going to use today in Pandas are very similar to the Excel functions. So the question is, why do we even need Pandas if we know Excel? One reason for that is that Microsoft Excel can only handle 1,000 rows of data without lagging behind, and it freezes repeatedly working with a big amount of data. So Pandas is a lot faster, and it can handle even 1 million rows of data without any problem. And in addition to that, Pandas supports the subsequent machine learning pipeline. So that makes it very convenient for the rest of the work. And also we can automate the cleanup of the data so that we don't have to do it manually every time. And but anyways, these are not the competitors. We can think of Excel and Pandas as complementary tools, because we store, many times we are loading the data from Excel files or CSV files. So the storing is very convenient in Excel, but for handling the data and for analysis, we use Pandas. Effectively, we will build today. What we will build today is the data analysis report on an example data set, and I want to go through the most important steps you need for making a data analysis report in general. So this is the link that we are going to use. You can use the shared link in the chat to follow along with me right now or later after you want to check the code and explore the code. All you need to do is to click the binder logo shown in this slide, and it will going to, you need to give it some time to set up all the required packages for you. And this is very convenient because you don't have to figure out what packages you need to install, and everything is going to be taken care of by itself. So let me stop the share and share the code with you. Let me know if you have any problems with the link. It shouldn't be, but just in case. Okay, this is the link shared with you. This is the GitHub repository that I have made for this workshop. And this is the main file. Can you let me stop share and can you see the GitHub repository?
Yes, we can see that.
Right. So the main file here is this Jupyter Notebook that we are going to use. And for your convenience, I have run the code in Binder. And if you click this, you will see that it is setting everything up for you. And this is if you have some kind of you want to report something, probably this is a good way to for someone who is not familiar with Python. You can set everything up for them so that it is very convenient for them to load. And Jupyter Notebooks are very popular right now for because they can have all different aspects of documentation. They can have code along with the visualization and the documentation and comments and everything together, and you can add any kind of graphics. So that's for the first part. I want you to use if you can work with me, along with me, you can hit Edge and you can see that these are all the shortcuts to be for your convenience. You can use a lot of these shortcuts that makes it easier to work with Jupyter Notebook. But many important ones I have listed here. For example, Control Enter is to run a cell, Alt Enter is to run the current cell and make a new cell afterwards, and Shift Enter is to run and move to the next existing cell. And so these are some important ones. For example, when you are in, there are, first of all, there are different types of cells in Jupyter, and the code and Markdown are the most used ones. When you have a code cell, you can hit Tab for completion, for code completion, and Shift Tab for help documentation. So whenever you have doubts about something or you don't remember, you can get help from these two. Okay, and so this is what we are going to do in this notebook. We are first going to learn what are the different ways of reading data into data frames. Data frames, basically, you can think of it as a table with columns of variables and records in the rows. And then we are going to work with the data frame, how we can edit it, how we can rename some columns, how we can add to it, how we can drop part of it, and then how to clean it up if there are some missing values, how to find them, and about the formattings, how to convert the formats to the right ones. And then we are going to the most important part is exploration. For example, let me show you some of the explorations that we are going to get into. For example, over here, we have the visualization at the end after we have cleaned, read the data set, cleaned it up and everything. We can then have some kind of visualization to have more insight over the data. And let me check. Is there anything in the chat that I need to? Okay. And so yeah, that's the end goal, to have some insightful visualization for our for the purpose of the business or for our own insight. So like every Jupyter notebook, the libraries are always loaded at the beginning of the code, so that you have everything set up right away, and then you get into the main code. The main code, I want to make you more familiar with the data frame. Data frame is nothing more than a table. And for the table, the most important part are the columns, and then the records are being added to the rows. So for example, over here, the PD is the short for pandas. We can, like most of you know, we can import pandas as PD, and this is the convention. And so then you can use PD dot to go into pandas and use all the methods and functions inside it. So data frame is the data structure in pandas. And then inside that, you want to give it the name of the columns, which we have defined here. So this is the list of columns that we are defining. And then let's, there are three main ways to read data into data frames. You can use list of lists like this. So this list of lists, each of the lists inside are one record, and they all together make different records. And we need to give the name of the columns separately, similar to the previous one. And this is going to load into a data frame using the pd.data frame. And then another way is to have it as a dictionary. Dictionaries have keys and values paired together. So the keys are the column names here, and the values are the records. So we can do it like this, and you can see we are going to have the same result. But the most common case is to use the already existent data set, which is in CSV file or Excel file. And you can use pd.read CSV to load your data set. So this is the data set that we are going to work with. And let me give you some information on this data set before we move on. Okay, this is, can you see my slide now?
It seems not, May. We are still in a web page.
Okay, let me show you how about now?
Yes, we're here.
Okay. So this is the data set that we are going to use. This is one of the Kaggle data sets, which is very important and used. And this is a scrapped data from a publicly available records of a website about the housing in Melbourne. And these are from 2017. And this data set has 21 columns, including address of the property, type of the real estate, price, the agent, date of sale, and distance from the central business district. So we can extract insight from the data set based on the columns that we have. So now with that, let's continue with the loading of the data set. Okay, so I hope you can see that we are loading the data set here with pd.read CSV. And then you can see how many records and how many columns using that shape. So you can, this df is short for data frame, and df.shape of the first shape is the number of records, and the second is the columns, the number of columns or the number of variables in the data set. And then you can use df.head, which defaults into showing the first 5 rows, but you can define some other number like 3 to have the 3 first rows depicted. Now let's say we want to make changes in this red data set. The data set, for example, one of the columns here is, if you use df.columns, you can see the list of the names of all the columns. And you can see one of them is called seller G, which for me is not very representative. I do understand it very well. But when I checked in the description, I see that this is real estate agent. So we can rename it for better understanding. This is how you rename, is df.rename, and you need a dictionary like this for renaming the current, to map the current name to the new name like this. And you can see after renaming, the list of the column names have changed like this. So this is seller G changed to real estate agent over here. So let's now move to adding, inserting, and dropping. So inserting the column is very simple. Like reading columns, you just write a new name column and assign a value to it. For example, you write the name of the column is test here, and we are assigning all the records in that column as test column. And once I run this, you see that this is the result added. At the end of the data frame, we have this new column added. But because this is no meaningful column, let's now drop it. To drop this, what you do, you use df.drop, and this is the name of the column that we want to drop, and this is all the access. And in place equal true means that we want to overwrite the data frame, the existing data frame, with the new one, so that now we don't have that column that we want to remove. Similarly, we can insert new rows into the data set using a dictionary. So you can see that, so to add a new record, you need to have all the values for all the variables, so all the columns. So this is the mapping of the columns to their value for this specific record that we have in a dictionary format, and you can append that into the end of the data frame. And again, the ignore index should be set to true to be able to append. And now let's, similar to head, we have also the tail method, in which we can see the end, the last rows. So the last two rows are now, after appending, you can see this new one that we have is now appended. So now to drop it is simply use the drop. Okay. To drop it is simply, we use the df.drop of the last one. This is the last index of the last row that we want to drop. And then you can see that the new row is now omitted. Okay. So far we created the data set, we read the data set, and we kind of played with it to rename it, to add to it, or drop some non-informative the columns or rows. But let's get into more to know more about this data set. This data set, like I said, has using .info is a good way to have a view of the data set. So over here, you can see that we have 21 columns. These are the name of the columns. These are the type of the columns. Many of them are object type. Object is when you don't assign a specific data type to a column. It automatically becomes object, because object is can be a mix of numbers and strings and everything. Then we need to clean everything up and assign more specific data types. And this shows how many points are in each of the columns, and which means that, for example, for this one, we have many empty or missing values, which we are going to handle. And then using .describe is a way to have some statistics, basic statistic, descriptive statistics like mean, standard deviation, and min, max, and median of the data for each of the columns. So this is another way to have gain some view over the data set. So now let's start with the formatting of the columns. So let's say the type is one of the columns, And let's see what we can do with it. Over here, let's first check what is the memory usage of the column. And then after we change it into a categorical data type, you can see that the memory used for this column has dropped by 43%. For this reason, it's very good, especially if you have very comparably few number of unique values in the dataset. You better changed it to a categorical type. It used to be an object, and now we have changed it to categorical using as type method. You use as type and set it to the value that you want, the type that you want. Now let's see how many unique values we have in the type. There are two ways you can refer to a column. You can use dot, the name of the column, or you can use parentheses with inside the semicolon. And so, yeah, like this, you can write it like this or like this. Both of them are referring to the same thing. And then using dot unique, you can see what are the unique values in this column, which you can see are H, U, and T. So I don't understand anything from H, U, and T, but checking the descriptions, it seems that it means house, unit, and townhouse. Okay, so the better idea is to replace them with more representative values. This is the way to replace. So we are narrowing down to type column, then we use dot to replace, and again we are using a dictionary to map the current values, the unique values that we have in this column, to the new values. And in place again is true to overwrite the data frame with the new one. Okay, and this is again to view distribution of the column based on the values. So we have 3 values, and using value counts and over here normalizing it, we can see about 70% of the records are houses, and so majority are houses, and then units, and townhouse is the least number of records. Please stop me and let me know if you have any question. We are not going too fast. So then, like I said, we better change the data types into categories when we can. So these are some other columns that we can do it for them. So we are just simply use as type and assign it as category. Okay. Now let's talk about missing values. So first, see if we have any missing values. So you use pd.isNull and give it the data frame df, and then .any in axis equals 0. This is to find the columns that have any missing data in them. And you can see that most of them have no missing value, except for this is true for the car. So the car column has missing values. And these are also true, these 3. And now let's see how many missing values there is. So to do that, we can use df.isNull.sum. So we sum over all the ones that are true, all the records that are true for isNull. And you can see that very small number of missing values there we have for cars, but these are very huge numbers because it's about third to half of the numbers are missing. So for that reason, we are simply omitting these columns because they are not very useful. And if we just assign any value to them, it's not going to be very valuable. So simply we use df, our data frame dot drop, and we set the name of the columns to the columns that we want to drop, and which are these columns that have so many missing values. And in place again is true to overwrite. So anytime you drop, use in place true if you want to keep the changes. Okay, so now let's see. Okay, so what to do with the car? We cannot explore the data when there is missing values in them. So we better first handle the missing values. So there are different things we can do. We can set the missing values to specific values. We can set them to mean value of that column. We can set them to 0, anything that is meaningful to us, and we can take the record of that. So this is what we are doing here. We are assigning, all the missing values. So we are filling the missing values with the mean value of the car column. And with that, after checking again, we see that there is no more any missing value for the car, and everything is in the every column, no column has missing values. So now let's move on to another conversion. So we need to, similar to what I said before in the presentation, many times the non-numerical columns are not saved as numerical, so we need to correct that. So, or there are, for example, many of the integer values are saved as floating numbers. So we need to use as type to set it to integer. So for car, it only the meaningful values are integers. Similar for rooms, for bathrooms, for price, for example, we need to set it as float. So these are converting the formats to the right formats. And another important conversion is for date. So dates are stored as objects because they are a mix of a string and numbers. So what you need to do, by the way, what I do to move from one line to the other line is I use shift enter. So you use shift enter to both run and move to the next cell. So that's you can also use that. And so for the dates, it is initially as an object type, but we want it to be a date type to be able to extract out its components, like the month, the day, anything that is meaningful to us. So this is what we do. We need to use one of the methods inside Pandas, which is to date time, this method. And this is going to convert the date column into the date type, and is going to overwrite the current date column with the new one. So when we can check, then we check that the type has changed now. Okay. Okay. So now after having done that, simply use this. This is referring to the column, then .dt .month is going to extract out the month from the dates, and then we can make a new column of the months, and we are going to use it later on, so you see how it is useful. For example, we can see how different months of the years are different in terms of the number of the properties sold or the price of the sold properties, things like that. So we are now adding that. Now if you check the head, you can see this new column is added at the end, which is taking the months column and writing. So it's very important to have the consistent format and have the right format. The major part of the work is cleaning, because not all the data sets are as clean as this. That you need to take care of that, and that's the main thing. So now let's say we want to sort the data into sorted by price. And when you sort values, this is how you do it, sort values. And this is by default is going to be ascending. So if you want it descending, you need to set it as false. And then every time you do the sorting, use reset index. This is what it's going to do. This is the previous index, prior index, and these are the new indexes. So what you are doing is that you are adding the previous indexes, now sorted indexes, into another column, a new column, and these indexes are sorted from 0 to the length of the data. So it's more convenient and sorted. Now, what can we do with the string columns? For example, for the address, this is a string. Everything inside it is, even the numbers are considered as a string. So what we can do, we can split it up. These are some regex methods that we can use over the strings. So first thing, let's say we know in the address, the last part of the address is the road type. Let's say that we want to add it as a column, as a new column, and for example, use it as for our analysis to see if road type has any effect, for example, on the price or something. So to do that, you first need to set the column, narrow down the column to address, and then .str to make it the short for a string, to make it a string. And then we use a split method to split by the inter between the words, and we want the last, this is to have the last string. So then using, we are setting this, assigning the row type to this, all this, and then when we check the unique values in this column, we see all different row types that there is in the data set. Okay, another important thing for string columns is to make them some standard format so that you can search inside them, or it's consistent every time. So for example, you either want to make everything uppercase using this, or you want to capitalize everything, you want to make everything lowercase, anything that you want, just you need to make it a standard format. Okay. Now let me show you some overview over this iloc, loc, and followed by Groupby are very used and very important methods in Pandas for filtering, for grouping, for extracting insight. So let me first show it from the slide so that you have better insight, and then use this as an example. Let me share. Okay. Can you see my slide now? Yeah, Groupby slide.
Yes.
Okay, great. So for the Groupby, this makes it very easy to understand. I hope many of you might have worked with it, but Groupby can be used as the first step in exploratory data analysis process, because it gives you an idea about the relationship between the different variables in the data set, and you can use it to aggregate and to see, for example, let's say for this one, you can see that the rows are grouped based on their color. So they are grouped based on color, all the yellows, all the green ones, and all the blue ones. And then they are aggregated based on the values over here for each of them. So they are aggregated based on the values, and then we can further sort them based on their values using sort values, similarly to what we had before. So this is the main idea behind the Groupby. Another important thing for you that have used Excel, you know, pivot tables can do something similar to grouping, but this is more than that. They can reorganize, summarize, and group the data points, and you can change the perspective basically into the data set using pivot tables. So for example, you can, instead of having all these columns, you can change the index to one of the columns and keep one of the columns values over here. So this is the same table looked at differently, basically. Another important function is iloc, which is to primarily, you need to have the integer positions that you want to filter. For example, let's say we want to have only the first row. So you need to give it the 0 for the first row inside df.iloc to filter it out. Or for example, over here, 0 and 2 is going to filter out the first and the third row, because this is starting from 0. And then once again, you can give it a column name as well. For example, you can give it 0 and 2. So comparing this with this, you can see these are inside a bracket, so that these are both referring to the row numbers. But over here, we have a comma, meaning that the row that we are interested in is 0, and the next one after comma is about the column number. So, and the column that we are interested in is column 3, 1, 2, 3, okay, or 0, 1, 2, starting from 0. And you can see this is going to filter out and give you 4, okay. And then this is another the more complex one, is to give it a couple of values for the row and a couple of values for the column. So we have, for example, over here we have 0 and 2 for the rows, and 1 and 3 for the columns. So basically, we are going to end up with these 4 values. We are going to filter out to these values. But as you can see, many times we don't know the value position of the cells that we are interested in. So the more useful way is to use loc. So at the beginning for the previous one was for the index, but many times we don't know the index, and we only are interested in the locations with some condition. So we use conditionals inside loc to filter out to our purpose. For example, let's say we want a specific column to be greater than 6, this shield column to be greater than 6. Then looking at this column, we see that only one of them is greater than 6, and this is going to give us that row that meets the condition. This basically translates, this inside condition translates into this list: false, false, true. So it means that the first row is false, the second row is false, and the third row is true. So that's basically what it does. It first understands it like this, and then gives you the rows for which we have the true condition as true. Okay, does that make sense? Okay, so now let's go to the example code for this. Hopefully that you have better insight now. Okay. So in this code, you can see that we can use loc, like similar to what I said, to have any sort of conditions that we want. For example, we want to filter out all the rows which type is house. So we set, this is the condition. We want the df type to be house, and we don't want all the columns to be show up. We only want to check the type, price, distance, and region name for that. So this is how we filter out the data set to narrow it down to what we are interested in. For example, let's say that we are interested in only houses that are very close to the center of the city, and they don't have many rooms, only 2 or less. And this is like our criteria, for example, let's say for a house that we are looking for. And then running that, you can see we have now narrowed down to only for about 400 rows of data from which we can extract more specific information. For example, let's say we want to know the mean value of those filtered records. And this is how you do that. You basically use the NumPy. This is NP short for NumPy. NumPy.mean is to take the mean of all the values of price inside this filtered by criteria data frame. And then you can see this is the price that we are looking at. This is kind of a not bad estimation for about 400 records. Okay. Now let's see an example of group by. So group by is to group the data by a specific column and then aggregate by another column. For example, over here we are what I have done over here is only for the purpose of visualization, because this is going to, if I didn't have this line, it would have shown also the time, and the time for this data set was all zeros, and it wasn't anything meaningful. So I'm just keeping the date part of the column in date only. And then I'm grouping by the date, because in each date we have more than one transaction, more than one property sold. We want to know how many properties on each of the days are sold. And so basically, if it is a uniform distribution, if it is not. And you can obviously clearly see that it is not anything near to uniform. So some days there are very so many properties sold, and some days not so much. Okay, so this is how we do it. We count, or we basically see how many from the fields exist. The price over here, it could have been any other field. For the count, it doesn't matter. So and it grouped by for each date. So in each date, how many transaction or how many properties sold. And then a more interesting thing we can do is to see the average price on each of the dates. So based on those transactions on that day, we want to see what have been the average of the price. So you can see this is a little bit more close to uniform. So this is how to use group by. Over here, we grouped the records based on their date. Another important thing is to be able to visualize the data and summarize it in to have better compact insight. So this is the box plot is a very useful plot, because you can see what is the main range of the data and what are the outliers, and how even you can go for taking care of the outliers to have a better part of the data saved. So this is how we plot the box plots. Over here, I have used Seaborn library. This is, yeah, over here, SNS is the short for Seaborn. And this is very convenient toolbar, a library that you can use, because basically what I have done, I have just simply given the data to it, the data frame, which I have sorted by type first, because I want to have some order to the data. And then I am telling it how I want to group and show the data. So the X is the type and the Y is the price. So the box plots on the price But before that, they are grouped into their types. So this is the end result. So they are grouped into their types, and for each type, we have a box plot of the prices. Okay. So and the rest of it. So this is the main line. So everything else is extra. What I'm doing over here is I'm basically, it's not as complex as it looks. It is just giving it a size and location and a color for these boxes that I overlaid on the plot, because I want to know what value, because these values are not very readable. I want to know what is the median, what is the mean of the data, things like that. I'm overlaying on the plot. And you can see that the mean price is 85,000, which is very low price of for a property in Melbourne. And let's see, one can be suspected or to want to check further why this is so low of a price. You can then go through the records. Again, you can filter it out to only have the mean price, mid price, and max price to be able to have a better view and compare. For example, someone might know about their address, the agent, and have some more information and want to check over that. And so this is how you do it. You basically, you are filtering the price column for those records that their price, you are filtering the whole data frame for those records that their price is within this list, is in this list of having the list, the minimum price, the median price, or the maximum price. Okay. And you can see this is the minimum price over here. Okay. And okay, this is another representation. So the violin plot has more information compared to box plot, because it shows you a kind of a kernel density estimation of the column that you are asking for. For example, over here we have X on the type, and then we are, instead of price, we have rooms, and we want to know the distribution of that. So it gives more information, because, for example, you can see that the most prevalent, or the most number of the houses have 3 rooms, and the townhouses have also 3 rooms, and units have most number of them have 2 rooms. But you can also see the distribution for the other values and all the existing values. This is so this axis is basically the count, the number of values. Okay, this is also interesting to, we want to group by the type and region name to see which region in the city is the most expensive, has the most expensive properties. So what basically we are doing, we are first, we are only interested in price, type, and region name. We are grouping by 2 things, region name and type, and we are aggregating the price, the mean price. What is shown here is the mean price. Okay. And then anytime you have grouped the data, you can use the dot plot and give it the kind of plot to visualize it. So this is basically, after group by, I am plotting it. So you can see that the most expensive region is and consistently among all the different types is southern metropolitan. So, and southern followed by eastern are the most expensive regions. Okay. So, and basically, I wanted to show you that you can do the same thing using pivot tables and group by. This was the group by version of it. this is the exact same thing, but done with pivot tables. So for the pivot, you should give the index, set the index to type, and values to price, and columns. These smaller columns are the region name. This is probably the more convenient way of doing it, but this is a matter of preference. So these two are the same thing done with two different ways. So let me run everything in this. And because we have limited time, I don't know if you want me to go over time or not. Probably not. So I'm going to, there's not much remaining, but let me show you this one. So this is because the data set that we have here has the latitude and longitude of the data. We can use that to overlay information on the map. And this is how you use that. This is the library used for it. One of the options is density map box. And you can use these two. So this takes the data frame and the location columns, latitude and longitude. And this is the color column. So basically based on the price, we want to have different colors on the map. And the radius is the radius of influence of each of the data points, because we have just one point. Each point can have different influence, a set amount of influence. And so the rest are some other properties to set the opacity, the color and everything, and the title. So this is basically shows you that the southern and eastern part are the most expensive parts. So this is very convenient way to depict something like that. And this is for the land size. You can see how the land size is different between different regions on the map. And then, okay, another important thing. Now I want to show you how I can use the month column. So for the month, I'm using pivot tables to have the similar to what we had before. You can see we can use pivot tables to group by type and have months as the columns. And this is count the number of transactions in each of them. And this is the mean price. So basically you can see that for all consistently between the different types of properties, it is shaped like a normal like shape for the price, meaning that in the middle of the year, we have more number of properties sold. And again, you can see in the middle of the year, as we have more properties sold, this result reflects basically the supply and demand rule, that when there are more transactions, the price drops. So you can see that in the middle of the year, price drops as the more properties are sold. So this is the same kind of pivot table used for this another kind of columns. Nan, would you want me to stop here?
Sure, I think we can stop here and ask.
This is a link. If anyone is interested, they can contact me if they have any questions. And also, you can use the link to further go through the rest of it. And just feel free to reach out if you had any questions.
Mm-hmm. So is there any questions from the audience?
Oh, yeah, yes. I do have one question. Could you provide your email address to us? Like, you can send that in the chat. I mean,
yeah, sure.
yeah, thank you so much.
You're welcome. And also I have shared, let me share the link to the Kaggle code. I have shared this code over there too, so you can comment everything. If you have any comments, you can also leave it there. That's basically